this video, we'll be looking at the maximum depth of binary tree algorithm. Currently, we are going through the shared algorithm series. The link is in the description. You can look through it and see how it looks like. It has a list of 180 algorithms, and we are currently on the 23rd algorithm, the maximum depth of binary tree. If you are new here, please subscribe, like, and share. Let's get into the video now. Now, it says that given the root of a binary tree, we are to return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So we're just looking for the maximum depth. You know, I think some videos ago we did that for the minimum depth, but this for the maximum depth. So practically the same, except now we are trying to get that which is the maximum depth. So I feel we could use BFS or DFS, but we'll be going for the DFS, the DFS. Since we are just trying to track the depth, we want to find which depth is the highest depth. So so basically that's just it. Can we have, okay, we can have a null value, that is no node exists there, and the values are from -100 to a +100. Okay, so let's just go to the board and see how we want to do this. So let's say we have a node here, another node here, another node here. Just for simplicity's sake, let's say we have one here. Now, we know that the longest depth is this big 3 of 3, because this is level 1, level 2, and level 3, basically. So, but here we now, so let's just say we have, let me just give it values 1, 2, 3, 4 for easy identification. So basically what we just want to do is we want to just cascade down, and we are just asking if this is 1, this is, we know this is the level 1, and if we get down, if it's a leaf node, because I think, let me check again. So here it said to the farthest leaf node, so it is at the leaf node. So let's go back. So, you know, we want to get to the leaf node, and the leaf node, of course, we know is a node that has no children at all. So we check, is this a leaf node? Is not a leaf node. So we go down to the next one, and we know, so we just need to increment our level for every depth we go. So at this point, we know we're at level 1. So when we get to this, we know we have to add 1 level. So we know at level 2. And then when we go to the next, we know we are adding 1 more level. So this is level 3. And so we're just asking at level 3, is it a, at this node here, which is level 3, of course, yes. Is it a leaf node? Yes, it's a leaf node. And since it's a leaf node, we can now check what height do we have there. We have 3. So all of this is cascaded back here, and then it has 3 from the left. And on the right side, it says, it cascades down to this place. It says this is level 2 now. And it asks, is this a leaf node? Yes, it's a leaf node. So it cascades the answer back 2. So we have 3 and we have 2. And we know that what we want is the highest depth. The depth here is 3, the depth here. So we want the maximum. So we just pick 3, which is the maximum of the 2. So basically, we'll be using the depth first search, and we'll be cascading in that particular manner and comparing for, checking for the maximum actually at each level, and cascade it back upward. So let's just see how we could bring this up. So so let me just create, let's have a max depth DFS tree node root. Okay, so I would like to keep track of level, right? So does this make sense? I think I could actually do without this. Let's see how it goes. So I think I can do without the level here, since I know, okay, so if I'm in a leaf node, so that is, if the left is null and the right is null, I know I'm in a leaf node, right? So if I'm in a leaf node, then I know I have gotten to, okay, so I can just return 1. And while I'm returning 1, I'm telling that, okay, this, I am a particular node is what I'm trying to say. So I'm a level, so return 1. But if it is just, if the root itself is null, that means I don't want that. So where root will be null will be, for example, if you come here where we have so here we have null here. So we do not want to account for this height here because this actually has no node, or this is also going to be null. We do not want to account for this height because this is actually, so we are returning 0 here. But for this one, we are returning 1. So we are saying we are returning 1 back here, basically, is what we are trying to say here. So let's see. So if it's the root is null, so we want to return 0, but if it finds, then we want to return 1. And then we want to check between the left and the right which of them is the highest. So I could just do max, and then I will just do the recursion here, depth first search, and I will pass in the left, and I will pass, okay, so this is going to be max depth dfs root dot right. So basically why I'm adding this +1 is I'm saying that, you know, for each level that we go down, I'm trying to tell it I am a level, check the other levels below. So if I come back to our diagram, let me just draw a simple, so at this level here, this is at level 1, at level 2, and at level 3. So at this level, I am saying that, okay, I want to cascade down, but before I go down, I want to add 1 to whatever this one has. So whatever this one have, I am adding 1. So the level is +1. Now this also goes down and cascade down and said, whatever you are, I am also adding 1. Now this is a leaf node with no children. So since it's a leaf node with no children, you know, when we have a leaf node, we are returning 1. So this node returns 1. So we have 1 plus 1, that is 2. So this is going to be 2 plus 1, that is 3. And then we have 3 here, pops up at the start. So if we go back, that's basically what we're trying to do here. So I'm checking for the left, and I'm adding 1 for the particular level I am, and for the right, I'm adding 1 for the particular level I am. So I don't really need to pass in any level. I'm keeping track of it with this +1. I keep passing through to it. So here, if I just return max depth dfs and I pass in the root, it should be fine. And remember, like in the last video, I did say that when the signatures are the same, as you can see, actually you don't really need to do this. It's just me doing it this way. I just prefer to do that and add the dfs to it, to the method name. So let's see. I believe this should be fine. Yeah, so let's see. Okay, yes, this passed. Let's submit, and hopefully we pass all the test cases. Yes. Oh, did it fail? Okay, yes, it passed. Okay, so basically that is how we go about to solve this. Maximum depth is like the opposite of the minimum depth, but I think for that we used levels and we are passing like a tuple. I think that was what we used there. You could also use that. I think it should work, but I don't know, thinking about it now, I could use this and that will also work for that. Yes, because all I'm doing is I'm passing in the depth at each level. But the problem with that now is that how will I account for the minimum, because one will be always, it will always say 1 is minimum. So probably this might not work for that actually. Anyways, this is the maximum depth of binary tree algorithm, and this is actually how we go about solving it. If we need a little clarification at any point, please drop a comment and I will respond. Thank you, and I'll see us again in the next video.